We've developed a tube that's able to pump liquid. It's a tube in the shape of a fiber, roughly 2 millimeters in diameter, and when we put a voltage on it, we're able to generate fluid flow and fluid pressure. Our interest is in wearable applications. Our clothes are made of fibers, and so what we wanted to do was develop a pump that can be integrated into our clothing so that we can make our clothing active, either for temperature control or in the future as a soft exoskeleton.
So here I have a thermal haptic glove that we've realized using our fiber pumps. So each finger has a separate fiber pump, and they're all connected to a reservoir of fluid on the back of the hand. And behind that reservoir, we can put some ice to chill down this fluid, and then each pump is individually controlled, so we can flow that cold fluid around each finger. And this is useful in a virtual reality setting to simulate the thermal properties of materials, because a lot of how we perceive the world is through its thermal properties. So for example, were I to touch this table, I could activate this pump here, and that would flow this chilled fluid around that finger, making this finger feel cold as I was touching the table. And now I introduce this finger, and this one starts to feel cold. Now here, I'm doing it in the real world, but in a virtual reality, this table might not even exist, but I can simulate the sensation of touching that table through its thermal properties using this glove.
So the pump is extremely small. It's in the shape of a fiber, roughly 2 millimeters in diameter. It's very soft and flexible. You can wrap it around. And a very important factor for us is that the amount of pressure we get depends on the length of the pump. The longer the pump, the higher the pressure. So if we're just trying to move fluid on a hand, we can have a small piece. If we're trying to generate much more pressure in order to create an exoskeleton, then we can have lengths of the fiber going up and down the sleeves or around the body.
And inside that tube, there are two helical electrodes that wind around the inside wall of that tube. We then apply a high voltage between those electrodes, and that ionizes and then accelerates a dielectric fluid inside the tube, which creates the flow of fluid. One of the main challenges was actually figuring out how to make a structure like this. The mechanism that we're using to generate the pressure and flow rate requires that the electrodes are in direct contact with the liquid in the middle of the pump. So we have to have our electrodes exposed on the inside wall, but also held firmly in the wall so they don't become dislodged. So one of the main challenges is actually figuring out how to create such a structure in a soft embodiment and at the length scale that we need.
So the next step, in the short term, we want to improve the efficiency. We're looking at different parameters in order to get higher electrical efficiency. And then we want to integrate it into full textiles, using not just the pump in the textile, but we would like the actuators, the part that does the mechanical deformation, to also be a fiber in the textile. We would like to add sensors that are also in a fiber format. And then you would have an intelligent exoskeleton able to sense, able to react, with even potentially the power supply in the shape also of a fiber.